Good morning, MYP1. I hope you are having a fantastic day. So, this is just a quick video to go through your MYP1 Mixtures Test, which, in case you didn't realize, was one of the chemistry topics. So, question 1, a meteorite landed on Earth. It contained a new element. A scientist put a piece of the meteorite in water and stirred it. This produced a blue solution with tiny solid black particles in it. He separated the black particles from the blue solution using the apparatus below. The black particles, what I would suggest you do is you highlight and make a note that that is a solid. The blue solution is obviously a liquid. Give the name of this method of separation. Well, if you look at the diagram, you should be able to see a conical flask, a funnel, and filter paper, with the filter paper obviously giving the method of separation away. So you should have the answer filtration, or you could have also written filtering. Next up, what do labels A and B show? So A is the black particles, and B is the blue solution. You could have also written the solid here, or the residue. And for the blue solution, you could have also put, say, the filtrate, or the solution, or the liquid. Some students for part A put this one, so this top one here, as the solute. Now I like what you're thinking, because B is the solution, but the solute would be dissolved in the solution, so it can't be the solute, because that would have made it through the filter paper. Next question, what happened to the liquid in the dish? So the liquid, or the water, evaporated. Now you should remember, evaporation is when we turn from a liquid to a gas. Liquid to a gas. Evaporation is interesting, actually. Most of the time, liquid to a gas is regarded as boiling. But boiling is when something reaches its boiling point, where every molecule in the water has the potential to turn to a gas. Evaporation only actually happens on the surface of a liquid. None of the molecules within the liquid itself are turning into gaseous state. Question 2. Reshma had a mixture of iron filings and sand. What could she use to separate the iron filings from the mixture? This one is a magnet. Why can the salt and sugar no longer be seen in the test tubes? It's because they are dissolved. Dissolved being the key word. Or you could have put, or they are soluble. Soluble. Lots of S words in this topic. Make sure you possibly have a little keyword list of solute, solution, solvent, soluble, insoluble. It's really important that you know the difference between each one. Next question, look at the diagram. How can you tell that a gas is given off? Well, you should be able to see nice little bubbles here, or representations of bubbles. And so that's all you needed to put. Bubbles formed in the diagram, or representation of bubbles in the diagram. So just to clarify, there was a color change. That could have been your answer. Or you could have put the water as darker, or brown, or grey. Next question, which mesh would be used best to separate the coffee from all of the ground up coffee beans? So you want quite a fine mesh, since you don't want any of the beans to be able to go through the mesh. No beans through the mesh. So this one is going to be D. The method for making coffee uses a type of filter paper. The apparatus used for filtration in a school laboratory is drawn below. So again, conical flask, funnel, and filter paper. Which part of the apparatus above works in the same way as a wire mesh? So that is P, and this is the filter paper. Next question. He wanted to separate the coffee mixture and the coffee solution and the water. So he did distillation, that's what this thing is called. Okay, and you've got this cold jacket here, or a condenser. And so the next question is asking, why did Russell put ice cubes around the glass tube? And it is essentially to cool the water vapor. To cool the water vapor back into water. Or instead of water vapor, you could have put the word steam. So to cool the steam back into water vapor. So it is a gas as it's leaving here. As it leaves the conical flask, it's a gas. As it then gets to this condenser, it's going to turn back to a liquid, and it then runs down into this test tube or boiling tube. Which leads nicely on to the next question. Russell heats the water. Water in the drink changes from liquid into gas, a gas. This change of state is called evaporation, and water vapor changes into a liquid. This change of state is called condensation. So when it hits the ice jacket, the water vapor turns back into a liquid, and this is called condensation. So you could have crossed those words off. We use condensation, evaporation, liquid, and a gas. If you thought about it, you could have probably ruled out an acid, since this isn't an acid topic. Crystallization could have potentially been one of the answers, but hopefully, if you revised state changes well enough, you'd know liquid to a gas is evaporation, and water vapor to a liquid is condensation. Next question is looking at food dyes, and we'll just skip through a few pages. So Gary wrote the labels on the paper in pencil. That's really important. Why did he do this? You could have had a few things, but essentially ink dissolves in water. So you don't want the ink to contaminate. You could have then also put the ink would smudge, or you could have also had would move up the filter paper, ink would move up the paper. You could have also had the pencil does not dissolve in water, or the ink expands, or the ink dissolves. Okay, any of those answers. Which food colouring contained the banned food dye? So if we look at the banned food dye, that's this one. You then had to look across as to which ones contained it. So this one is the only one which contains the same as the banned food dye. Look back down and your answer is yellow. Which food colouring contained the most dyes? So we're looking for the most dots. Well, blue has 1 dot, green has 2 dots, brown, because remember they run this way. Okay. Brown has 1, 2, 3, and yellow has 1, 2. So clearly brown is the winner. So your next answer is brown. just to recap the yellow food dye, the banned food dye had this mark, and the only other food dye with that mark was the yellow one. Which food dye did not dissolve in the water? Well, that's the one with no readings whatsoever, and so that is clearly the red one, since there isn't anything that has run up the paper. So that would be red. What method did Gary use to separate the dyes? This is called chromatography. Question 5. Chris separated the sand from the salt water. So you have done this practical. What method of separation is this? This is filtration again, because we've got a filter paper. What is substance A? So substance A in this instance is going to be the salt. You could have also put the residue. What is the part labeled B? And that is the filter paper. Next question, look at the two readings on the balance, work out the decrease in mass. This is 150 and 50, so it's 150 minus 50 equals 100. 0.0 if you were going to be exact, and well done to those people that were. So 100.0 grams. After 1 week there was a white solid but no liquid in the dish. So where in your practical you heated it up to speed up the process, they actually just left the dish off to the side, and for 1 week, within that week all the water had evaporated, and so the key word there being evaporated. So essentially the liquid in the dish turned to a gas. What was the white solid left in the dish? This would have been the salt. Suggest how John or a teacher could clear up the mixture safely without cutting themselves. So essentially there's been a breakage of glass. And the key thing would be to use a dustpan and brush. Dustpan and brush, or sweep it up. You could have put, obviously try not to pick it up with your hands, or don't pick it up with your hands. You're going to pick it up with a dustpan and brush. Why did some crystals and pieces of glass stay in the sieve? Really simply, they were bigger than the holes of the sieve. They were bigger than the holes of the sieve. Why did the water turn blue? So the copper sulfate dissolved. The copper sulfate dissolved. Dissolved being the key word there. Or you could have said the copper sulfate turns it blue. Why did the volume decrease? Water evaporated. So water left the dish and turned to a gas. The next day there was no liquid left. What would be left in the dish? Crystals. Or you could have said the copper sulfate, or copper sulfate crystals. Next question. Samantha opened a tin of white paint. The paint consisted of a liquid and particles of titanium dioxide, which are insoluble in the liquid. What type of substance is the paint? Well, you've got two things there. If we highlight it in the question, we've got a liquid and we've got titanium dioxide. So those two aren't chemically bonded, so it is a mixture. What type of substance is titanium dioxide? It is a compound. It has two or more elements. Okay, two or more elements. Why did the particles of insoluble titanium oxide sink to the bottom? You could have put they are heavier, or they are denser than the liquid. You could have put they are heavier than the liquid. So either of those two answers. So Samantha could not get the paint off the glass with water. When she used a different liquid called white spirit, the paint came off. Why could she remove the paint with white spirit but not water? You just need to say it is insoluble. So here are those key words: insoluble in water. You could have also said water is not a solvent, another key word for paint. So it was really important you understood those key words to answer this question. You could have also said it dissolves in white spirit. So it dissolves in white spirit. Or white spirit is a solvent for paint. Next question, tick one box for each statement. Water is a solvent for salt. That's true. You have used it as a solvent. This being the solvent being the substance which the solute can dissolve in. So in this instance, salt would be the solute. Sand sinks in water because water is more dense than sand. Well, water is not more dense than sand. If it was that way round, the sand would float. So that is clearly false. When a solid dissolves in water, the sand is called a solute. That is also true. So 2 marks. If you got one of them correct, you would have got 1 mark. 2 of them correct, you would have got 1 mark. All 3 for 2 marks. It wasn't 1 mark each. Describe what Amy can do to separate and collect pure water from seawater. So she can evaporate the water and then condense the water vapor. Okay, for 2 marks. So she wants to keep the key, crucial thing here being collect the pure water. Yes, she doesn't just want to evaporate the water and let it go. So you evaporate the water, but then you need to condense that water vapor. And you could have essentially said distillation for 2 marks, because this is what distillation is. Moving on. Seawater is a mixture of lots of different things. A salt is a compound and oxygen is an element. Then a compound is 2 or more atoms which are chemically joined. A mixture contains 2 or more types of molecules which can be physically separated, and an element, it contains only 1 type of atom. Moving on to the final question, you give the letter to represent a mixture of 2 elements. So this one is A. You couldn't have had any 2 circles which are differently coloured, chemically joined. So A has 1 element, and there is the second element. Give the letter of the diagram which shows a mixture of 2 compounds. So this one is E, because we've got 1 compound there and another compound there. Give the name of a diagram which shows a mixture of an element and a compound. So in this instance, this one is the element and this one is the compound, because the compound has 2 different colors and the element has the same color, and so this one is C. You can also, it's important to note, this is also a molecule, and this is also a molecule, and this is also a molecule. So a molecule is 2 or more atoms chemically joined, but they don't necessarily have to be different atoms. Okay? Give 1 difference between a compound and a mixture. Give 1 difference between a compound and a mixture. A compound contains two or more different atoms chemically joined. Okay, thank you.